Hey, good morning, everyone. So today we will discuss the test question 2. Okay, as I promised in the last session. So if you remember, we had a question like this where we have given the what is the transducer. This is actually LM35. Okay, if you notice, and then we have like a one more block diagram which is known as a non-inverting amplifier and ADC. Okay, and here the question actually asks, explain the purpose of non-inverting amplifier in figure 1. What is the purpose of non-inverting amplifier? Okay, if you don't answer, I won't go for the next stage. We won't discuss. I want to have like a communication, two-way communication today. Don't type in the chat box because I cannot see. I can't go and open there and see. So if you want to answer, you have to turn on your mic and answer. What is the purpose of non-inverting amplifier?
to amplify the signal from uh, LM35.
Okay, if you answer to amplify the signal from LM35, you won't get full mark because we know amplifier is actually to amplify signal, correct or not? But in context of electronic instrumentation, you have a sensor and then you have an amplifier. We know that amplifier going to amplify. Even in the amplifier word, we have the amplify, correct or not? So it's not a great deal to answer like that. What is the, I mean, amplifier function actually to amplify, but by amplifying the signal, what it actually can do here. I've mentioned this one in the
The,
class before this. Yes?
to utilize the full range of the ADC.
Okay, to utilize the full range of the ADC, that's actually one of the answer. One more. The main thing that we want to have here. I've mentioned about this before this many times. One is actually fully utilize the ADC. Okay. Otherwise, by fully utilizing the ADC, actually what can happen actually?
Increase the sensitivity.
Increase the sensitivity. Okay. So you see, amplifying signal. If you put means, I'll give like 1 mark. Okay. Additionally, if you say that if you want to fully utilize the ADC so that the sensitivity can be increased, means you get 2 marks. Okay, so here like this. Okay, don't need to be exactly same like this, but somehow you can answer like that, means it should be okay. Sketch the non-inverting amplifier. This is the answer. You just need to sketch. Some people actually calculate it. If you calculate also, we give marks. uh, if you what to call draw a wrong amplifier, maybe you get like 1 mark. Okay, and then calculate the feedback resistor RF value of the amplifier if the input resistor RI value is 10k. So RI actually already given. You know the transfer function of the non-inverting amplifier like this, right? So okay, the what I see in the exam paper, almost like a 20% of the class they did this mistake. Okay, they did this mistake. What is the VI of the amplifier input here? This is the VI. This is the VI, correct or not? This is the VI, and then you have the amplifier. This should be the V out. Okay, VI here, V out here. Mana lah? Oh, okay. Taking time. Okay, this is the VI. Input of the amplifier is actually VI. And this is V out. Okay, so V out equals to 1 plus RF over RI VI. So VI is actually from the non-inverting amplifier, we will take the maximum value. Maximum value is actually 80 degrees Celsius. 80 degrees Celsius, you multiply with 0.01, you will have like a 0.8 volt. And then the V out, actually 5 volt, the reference voltage will become the output of the amplifier. So we put here as the V out. Then we can proceed with the calculation so that you can find the RF. It's actually 52. I forgot to minus 1 here in the solution. Minus 4. Oh, sorry. Plus 1, you have plus 1 here. Okay. So you have to calculate like this. But what usually, I mean, many students, around 20% of the students, what they did, they put 0.8 here. They put 0.8 here. And then they put 5 here. So if you do like this, means actually finish the question, you'll get like a negative answer. Doesn't make sense. I don't know how you did this mistake. But in the future assessment, any assessment, don't do like this for your finals or anything. Okay. So this one, out of how many marks are this one? 3 or 4? Forgot. 4 marks. 4 marks. Either you get like a 2 or 1. Okay. Because totally wrong, the process. And some actually, like I did the mistake here, you didn't minus the 1. And some what they did, macam-macam lah. I mean, after here they do a lot of like a SPM level of calculation error. Okay, you had time, so supposedly you should have double checked. Okay, very, I mean, lot of funny mistakes here. Okay, so anyway, so try to avoid calculation error during the final exam. Okay. Initial error, this is actually very unacceptable error because you don't know the concept. Okay, but here some had like a calculation error. So okay, then next, sketch an alternative amplifier circuit that could replace the non-inverting amplifier. So here we had the range from 0 to 80. Okay, and we used non-inverting amplifier here. So what should be the alternative amplifier? The amplifier that can replace the non-inverting amplifier here. What is the answer?
Differential.
Differential. Why? Maybe you answered that one in the exam, I think. Why differential?
Yeah, I answered in the exam.
Nah, that's why. But you already know your mistake. Don't want to answer that. I know you guys. Very smart guys. Differential cannot be the right answer. Why? Anyone can answer? We have discussed this one many times, Why differential couldn't be the right answer? If you don't want to answer, I won't go to the next solution. This is the way today I'm going to have the class.
Only one V out.
No, anything will have only one V out, whether differential or non-inverting or inverting. Everything actually will have one V out. But the purpose here, you see, I don't want you to do the mistake again because sometimes in the final exam, you could have the possibility to choose the right amplifier among the 3. Okay, I've mentioned this one many times. Why you cannot use differential amplifier for this case? Must use inverting amplifier. Yes, come again.
Because
it's 0 Celsius.
0 Celsius. 0 Celsius is actually, it's not fully correct, 0 Celsius is actually okay, but not fully correct. 0 Celsius, and that 0 Celsius will produce 0 volt here, minimum voltage. Don't confuse the 0 Celsius, because sometimes for other sensors like thermistor, NTC, even though 0 Celsius, you cannot use inverting, because 0 Celsius for thermistor won't produce 0 voltage here. But for this case, 0 Celsius actually will produce 0 volt here. So that actually makes sense that you have to use inverting or non-inverting. You will have 0 volt, and this one you have 0.8. So for this case, either you use non-inverting or inverting, because the circuit actually won't get complex. You still can use differential amplifier, it can work, but why you want to add another 2 resistor over there? Another 2 resistor, yeah. Okay. So if you give the right answer, you'll get 3 marks. If you get the wrong answer, you either get 2 or 1 marks. Depends. If, for example, let's say inverting amplifier, you draw wrongly. It's not. You did some mistake, you'll get 2 marks. But it's not a inverting amplifier. You give like a wrong amplifier, you'll get 1 marks only. Okay. Then I mean for test, I'll be very quite strict. Okay. Test actually quite strict in the marking. But final exam, I'll be very generous. Don't worry. Because here the test actually, this is actually one question, actually 20 marks, correct or not? This 20 marks actually will be divided by 4. That actually will be the mark for your for the whole assessment. So let's say you got like you lose like a 4 marks here, 16, but actually you get like a 4 out of 5. So don't worry about the losing marks in this test, unless you did like the whole question stupid mistake, you didn't do, you don't know we had some students like that. They don't even, okay, cannot answer this one, okay, maybe you didn't listen to in my class properly. This one cannot draw. Okay, I already tell that before test, please remember the amplifier, this one cannot draw. And the equation, many of you actually put, I don't know lah where you created the equation. Many of you put minus over here, I tengok pun pening kepala. Okay, 1 minus RF over RI. So things like this, I don't know how to help. Okay, and sketch an amplifier, this one actually okay, tricky question, acceptable. Okay, then we go to the part E. Okay, part E, we clearly mentioned that use this thermistor with this thermistor TN80. But I don't know why during the test you still ask me which one to use. You are not confident by reading the question. I don't know why. Please be confident. Unless if it is any mistake, you can actually inform me. But like one girl actually informed me that it doesn't make sense, 80 to 100. Okay. So then I changed. But like this actually clearly mentioned TN80. Still you are not confident, asking either to use or this. Then as for the the temperature, okay, you see, and if the 10 millivolt per degree Celsius standard is replaced with the PTC thermistor, if this is replaced with the PTC thermistor, okay, they ask what would be the V out here of this one, maximum and minimum. But what you what you did here is actually you still confused with the temperature range. Some of you actually use the temperature range that we discussed in the tutorial. You use the temperature range because we discussed in the not tutorial, in the lecture, I think. Some actually use this range, 100 to 125. You stick with this 100 and 125, you just proceed with that. But here the temperature actually already changed. Okay, because some students think that, okay, once I have this one, this is exactly same like a tutorial question. Okay, so they just proceed with the temperature. Read the question properly and answer. Okay. So here in this case, this is actually 0 to 80. So 0 is actually here. You will have about 40 to 60, any number you choose, okay. I choose like a 50. No need to be very